So this is number 9, have a go. Okay, so we've got to find the point A which lies on the line L1. We know the y coordinate is 4, so just substitute 4 into the formula, the equation of the line. So 4 4s are 16, add 3 is 19. 19 equals 2x, so x equals 19 over 2. Now for part B, we're going to be using the big formula y minus y1 equals mx minus x1 to find the equation of a line. We know a point on the line, which is C, so we know x1 is going to be 2 and y1 is going to be 4. What we don't know is the gradient of this perpendicular line. So go back to our original L1, rearrange it into the format of y equals mx plus c, and we see that the gradient of that line is a half. So the gradient of our perpendicular line, L2, is going to be, flip it over, change the sign, is going to be minus 2. So substitute that in, pop it in the format that they require, and we get that as an answer. Now, part C, find the coordinates where they intersect. We've just got to solve the simultaneous equation. So best to use for L1 are our new y equals mx plus c formula. So that's our L1, that's our L2, and just substitute in. So substitute in half x minus 3/4 into the second formula, replacing the y, and then sort of follow through the algebra, and we get x being 3.5. We can then substitute that into either to work out what the y coordinate is, so we get d being 3.5 and 1. Now part D is straightforward enough to show the length of CD. Do a quick sketch just to help you gather your thoughts. We know the coordinates of C and D, so drop down a perpendicular and a horizontal. We can work out those lengths from the coordinates, and then it's a simple Pythagoras to work out the length CD and prove it is what they said it would be. Now E is very tricky. I think the best thing to do is just plot your points A and C, and then we know that that D is the intersect of the two lines L1 and L2, so just pop in those red lines, making it about 90 degrees, and then really B and E just pop down anywhere, just so you get some sort of sketch. We don't know those coordinates. Now we know the length CD. We can work out the length DE because we're told that CE is 3 lots of CD, so DE is 2 lots of CD, so that's, rather than being 1.5 lots of root 5, it's 3 lots of root 5. We know the whole length from B to A. So basically treat that equilateral quadrilateral shape, as the two triangles ACB and BAE, where they've both got the same base, which is the root 80, and the first one's got that as the perpendicular height, the second one's got that as the perpendicular height. So it's half times base times height on 2 occasions. Add those together and we get the answer of 45. Now I thought that was a very tricky 3 marks.